Good morning, and sorry I can't be with you today, but here is what we're going to go through today. I'm going to go through on this video. Day 35, that's today, Monday, 4/12. I'm going to go through the stuff. You don't have to watch this whole video. If you want to just go through these review pages, 415, 414, and 415 on your own, and then check your answers, okay? And then the skills practice, just these four parts of the problems on 114 skills practice. And then there's going to be a quiz, and I will put details about what the quiz and where to find it and all that stuff in the updates section. So you will update that by Wednesday night at midnight. All right, so let's get started. What we're looking at right here is page 414. I'm going to go through every one of these problems, explain how to do every single one of these problems, okay? This one, we're showing that this identity is true. We're going to work from left to right. If you'll notice this, we've got a cosine of 2x. Our argument, our angle is 2x. Here our angle is x. There's no way we can combine these when the angles are different, when the one's a 2x and one's a 1x. So we have to break this cosine of 2x down to be in terms of 1x. So you look at your double angle formulas. Cosine of 2x, we've got three choices. Now we could have turn that into cosine squared x minus sine squared x. Okay, not a bad option. We could use this one, 1 minus 2 sine squared x. I kind of like that one because we have a 2 sine squared x. We could also use this one. All three of them will work. I'm going to pick this one. Okay, I'm going to turn cosine of 2x into 1 minus 2 sine squared x. Bring down this plus 2 sine squared x. Show that that should be equal to 1. Minus sine squared x plus, or minus 2 sine squared x plus 2 sine squared x, those go away, and we simply get 1. Boom, that is what we were supposed to get. So that's all there is to that one. Okay. Next one, you've got a couple options. I would think about getting common denominators. I've got two terms, I have to combine them into one term. It's not the only way to do it. You could simplify this first and then see what happens, but I'm going to get common denominators. Secant of x over sine x minus sine x over cosine x. I'm going to get the denominators to both be sine x cosine x, so this I'll multiply by cosine x over cosine x. This I'll multiply by sine x over sine x. So my common denominator is cosine x times sine x. Here I've got a cosine x, secant x, minus sine squared x. Okay, maybe you'll recognize cosine x times secant x is 1. Secant x is just 1 over cosine x, so your cosines would cancel. This just becomes a 1, so you get 1 minus sine squared x over cosine x sine x. Okay, 1 minus sine squared x is equal to cosine squared x, because remember that sine squared x plus cosine squared x equals 1. So if you subtract the sine squared x to the other side, you'll get cosine squared x equals 1 minus sine squared x. So we turn that into cosine squared x all over cosine x sine x, keeping an eye on what we want this to become. Okay. This cosine x cancels with one of these cosine x's. We'll cancel it with the square. We end up with cosine x over sine x, which is cotangent of x, and we're done. Okay. Next question. Sine of 90 plus theta equals cosine x. So here I'm going to use this formula for sine of a plus b. Sine of a plus b right here. Okay, sine of a plus b, that's going to be sine of your first angle times cosine of your second angle plus cosine of your first angle times the sine of your second angle. So that becomes sine of 90 times cosine of theta. And we've got plus cosine of 90 times sine of theta. Okay, sine of 90. We draw a 90-degree angle. That gets us up here, 0, 1. Sine of 90 is 1. So 1 times cosine theta plus cosine of 90. Well, cosine of 90 is 0. 0 times sine theta. 0 times anything is 0. So we simply get 1 times cosine theta, which is cosine theta, which is what we were hoping to get. Okay. Next one, here we can do the same thing, sine of a plus b, and then cosine of a plus b, and hope that simplifies. There's actually a shortcut with a formula we haven't done. If you recognize this down here, sine of a plus b. Oh no, doesn't work. I thought maybe it was one of these. We can actually use a manipulation with one of these. But let's do this the same way we did this first one. Okay, so this is going to be using the same formula we used over here. Sine of a plus b. So that is this one right here. Following along, we're going to get sine of x cosine 30 plus cosine x sine 30. Okay, so that's this entire thing. Then plus this one, cosine x plus 60. So we're going to use the second formula, cosine of a plus b. Cosine a cosine b minus sine a sine b. So that's going to be cosine x cosine 60 minus sine x sine 60. Okay, simplifying, we've got sine x cosine of 30. 30 degrees looks like this. Rad 3 over 2 and 1/2. Cosine of 30 is rad 3 over 2 plus cosine x sine of 30 is 1/2 plus cosine x cosine 60. 60-degree angle, you've got the 1/2 here and the rad 3 over 2 here. Okay, so cosine 60 is going to be 1/2 minus sine x times sine of 60. Sine of 60 is rad 3 over 2. Okay, so here we have a sine x times rad 3 over 2 minus a sine x rad 3 over 2. Those cancel. Okay, because you're subtracting the same thing, you get 0. So this is 1/2 cosine x plus another 1/2 cosine x. 1/2 of this plus 1/2 of this gives you 1/2 of this cosine x. That is what we were looking for. Okay. Next one, sine of 165. We're going to break that down. There are many ways you can break this down. I usually look for a 45. That would be 45 plus what? 120. And both of these are good because both of these, this has a reference angle of 45. This has a reference angle of 60. Okay, you can draw them both if you'd like. The 45-degree angle is here, which is a rad 2 over 2 and a rad 2 over 2. The 120 angle gets you over here with a 60-degree reference angle. That was the 120. With a rad 3 over 2 and a negative 1/2. Okay, the formula for sine of a plus b, that's going to be sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. Okay. I'm just using this formula, sine of a plus b here. Sine a cosine b plus cosine a sine b. Okay. Sine of 45 is going to be this, rad 3 over 2. Cosine of 120 gives us this, negative 1/2, plus cosine 45, rad 2 over 2. Ooh, sorry, this was a rad 2 over 2. Can't read my own writing. Sine of 45 was rad 2 over 2. Okay. And sine of 120 is rad 3 over 2. So I get negative rad 2 over 4 plus rad 6 over 4. And tangent of 15, we could rewrite that as tangent of, I think the easiest one is just 45 minus 30. You could do 60 minus 45. Any two numbers that when you subtract them, you get 15. And so for that formula, we're going to do tangent of a minus b. Tangent of a minus b is this one right here. Tangent a minus tan b. That's going to be tangent 45 minus tangent 30 over 1 minus tan 45 tan 30. Okay. You want to draw your angles. The 45-degree angle has a rad 2 over 2 and a rad 2 over 2. So the tangent of 45 is this divided by this, which is 1, and minus tangent of 30. 1/2 divided by rad 3 over 2. When you simplify that, you're going to get 1 over rad 3 or rad 3 over 3. And you've got 1 minus tangent of 45 is 1. Tangent of 30 is rad 3 over 3. Okay, so we get 1. Let's get common denominators up here. That's going to be 3 over 3 minus rad 3 over 3. So that's 3 minus rad 3 over 3. Down here we'll get common denominators again. We'll get 3 over 3 minus rad 3 over 3. So one of these should have been a plus. The bottom one is a plus, sorry. I just followed that formula incorrectly. Looking at the formula again. Tangent of a minus b, it's tan a minus tan b over 1 plus tan a tan b. Okay, so on the bottom you get 3 plus rad 3 all over 3. These end up canceling, and you get 3 minus rad 3 over 3 plus rad 3. Make sure you can see that. That's 3 minus rad 3. Now, getting rid of the radical in the denominator, we're going to multiply by the conjugate of the denominators. 3 minus rad 3. 3 minus rad 3. Okay, a little bit running out of space. Let's do this. I'll just go up this way. So on the top, we're going to get 9 minus 3 rad 3 minus another 3 rad 3. So 9 minus 6 rad 3. And then plus 3. On the bottom, we're going to get 9. And notice it's a plus and a minus, so the outers can't and the inners cancel, and then we get minus 3. Okay, let's move up this way. That's going to be 12 minus 6 rad 3 divided by 6. And finally, 12 divided by 6 is 2 minus 6 rad 3 over 6 is rad 3. Okay, and let's go on to the next page. Next page is going to be 415. Okay, so we're finding sine of 2x, cosine 2x, and tan 2x for each, given the quadrant and the terminal side. Okay, so sine of 2x, the formula is 2 sine x cosine x. Let's draw x in the second quadrant, which is given. Okay. And the sine of x is 4 over 5, so 4 over 5, that's a 3, 4, 5, so we get a 3 here. So 2 times the sine of x, which is 4/5, also given, times the cosine of x, which is negative 3/5, which equals 2 times 4, 8 times negative 3, negative 24 over 25, sine of 2x. Cosine 2x, you have 3 choices. Let's just pick the second one, 1 minus 2 sine squared x. All 3 should give you the same answer. So 1 minus 2 times the sine of x squared, and the sine of x was given. We can also see it in our picture, 4 over 5. So 1 minus 2 times 16 over 25, or 1 minus 32 over 25. That's going to be 25 over 25 minus 32 over 25, and we get negative 7 over 25. Tangent 2x is 2 tan x over 1 minus tan squared x. So 2 tan x over 1 minus tan squared x. So looking at our picture when we drew x, tangent of x is negative 4 over 3. So we get 2 times negative 4 over 3 over 1 minus negative 4 over 3 squared. That's going to give you negative 8 over 3 divided by 1 minus 16 over 9. Okay, so negative 8 over 3. That's 9 over 9 minus 16 over 9, which is negative 7 over 9. Okay, so you get negative 8 thirds times negative 9 sevenths. These can reduce to a 1 and a 3, and you get negative 24 over 7. Actually, I think that's positive because it's negative times a negative. So 24 over 7. Okay, and let's look at this one. Cosine of x is negative 2/3, and we're in the third quadrant. Again, we're going to draw x in the third quadrant. And we've got a negative 2 over 3. Cosine of x is adjacent over hypotenuse. This side is going to be the square root of negative square root of 5. We do a squared plus b squared equals c squared. That's going to be 4 plus 5 equals 9. Okay, sine of 2x, 2 sine x cosine x, which is 2 times the sine x, is opposite over hypotenuse, so negative rad 5 over 3 times cosine x, which is adjacent over hypotenuse, negative 2 over 3. We get negative times a negative is positive, 4 rad 5 over 9. Okay, cosine of 2x, let's use a different one this time. Let's do 2 cosine squared x minus 1. So 2 cosine x is negative 2/3. We'll square it, minus 1. 2 times 4 over 9 minus 1. That's going to be 8 over 9 minus 1, or 9 over 9. We get negative 1 over 9. Tangent 2x. Another thing that we could do, tangent 2x, we could just do sine 2x over cosine 2x and divide these. Okay? Or we can use the formula. Let's practice using the formula. Tangent 2x is 2 tan x over 1 minus tan squared x, or 2, tangent x is going to be rad 5 over 2 over 1 minus rad 5 over 2 squared. Okay, so that's going to be rad 5 on the top, the 2's cancel. The bottom we've got 1 minus, square that, we'll get a 5 over 4. So we get rad 5 over 4 fourths minus 5 fourths gives you negative 1/4. So that's going to be rad 5. Instead of dividing by negative 1/4, we're multiplying by negative 4 over 1, and we get negative 4 rad 5. Okay, we could double check that should be equal to sine 2x over cosine 2x. This divided by this, notice the 9's will cancel and you'll get negative 4 rad 5. So that works. Okay, just for fun, we could check this one too. Tangent of 2x should equal this divided by this. So this divided by this, the negatives cancel, you should get positive, and the 25's cancel, you get 24 over 7. Perfect. Okay. Now, these two are fun on the bottom. Cosine of 2 times this thing. This looks like a mess. It's actually not too bad. These are kind of fun. Okay. Remember that arc sine of 5/7, remember that that is an angle. So we'll treat that as an angle. Let theta equal arc sine of 5/7, which means the sine of theta equals 5/7. Okay, it's a capital arc sine, which means inverse sine is between -pi/2 and +pi/2. So that means it's got to be in the first quadrant if sine theta is positive. We've got 5/7. This side would be square root of 49 minus 25. 49 minus 25 gives you 24. So square root of negative square root of 24, or -2 rad 6. Okay, so what we really have is cosine of 2 times an angle. Cosine of 2 theta. Okay, so we have a formula for cosine of 2 theta. I just drew theta. I took this and I drew theta. Here's theta. Because I'm going to need this triangle to figure out this once I plug in the formula. So we could do cosine squared theta minus sine squared theta. Remember, this is the one we have 3 options. Okay. I don't know. Let's use 1 minus sine squared theta, or 1 minus 2 sine squared theta. Cosine 2 theta equals 1 minus 2 sine squared theta. That seems to be one of my favorite ones. Cosine of 2x equals 1 minus 2 sine squared x. Okay, and then I've got 1 minus 2 times sine of theta. Now I drew theta, so I'm going to use sine of theta, which is 5/7, and square it. Okay, so 1 minus 2 times 25/49 equals 1 minus 50/49, which is 49/49 minus 50/49, which gives me -1/49. Okay. Now let's try that again. We've got another one right here. Sine of 2 times an angle. I'm going to name this angle theta because I know I've got a formula of sine of 2 theta. This part right here is my angle. I just called that theta. Let theta equal arctan of 3/4, which means tangent of theta equals 3/4. I've got a capital A, so that angle we know is between -pi/2 and pi/2. Okay, tangent of our angle is positive, so we know it's up here. That's going to be a 3 and a 4, which means it's a 3, 4, 5. I just drew theta. Draw theta. Sine of 2 theta is 2 sine theta cosine theta. 2 times sine theta times cosine theta. Let's look at our drawing of theta to figure out the sine theta. Sine theta is 3/5. Cosine theta is 4/5. And I get 2 times 3, 6 times 4, 24/25. Okay. Notice we never had to find theta. We had to find the sine of 2 theta, or the cosine of 2 theta. Okay. Let's go to that last sheet, the skills practice sheet, where we're just doing a few problems on these. And I'm going to actually do these on a separate sheet of paper because there's not a lot of room here. Okay. We're just doing D and G. D, we're going to need a calculator just to verify. But we're verifying the half angle argument works by substituting directly and then using the formula. Okay. So I'm going to do cosine of 1/2 x directly, and then I'm going to do cosine of 1/2 x using the formula, which is plus or minus square root of 1/2 times, let's just show where this is coming from. Cosine of 1/2 x is plus or minus 1/2 times 1 plus cosine x. Okay. Now I know x is 390. So 1/2 x has to be half of that. So 150 plus 45, 195. Okay. Now, where would 1/2 x be? 1/2 x gets me over here, right? 195. So we're going to end up in quadrant 3. 1/2 x is in quadrant 3. That's going to come in handy. That's going to be important. Okay. So I'm going to highlight that. 1/2 x is in quadrant 3. We need that to figure out this thing over here, the plus or the minus. Okay, because if 1/2 x is in quadrant 3, we know that the cosine of that angle is going to be negative. So right now we know it's going to be negative. Okay. So this one we're going to plug in 1/2 x is 195. So this is just going to be the cosine of 195. Okay, we could do that without a calculator. Actually, maybe for fun we could. Cosine of, I'd do 45 plus, what is that, 150? And we use our formula for cosine of a plus b. It's going to be cosine 45, cosine 150 minus sine 45, sine 150. Cosine 45 is rad 2 over 2. Cosine 150, that gets you over here. That's negative rad 3 over 2. Minus sine of 45 is rad 2 over 2. Sine of 150 is 1/2. So I get negative rad 6 over 4 minus rad 2 over 4. Okay, so we have to show that we get the same thing when we plug this into the formula. So plus or minus, we know that 1/2 x is in quadrant 3. The cosine of an angle in quadrant 3 is negative, so that's going to be negative 1/2, 1 plus cosine x, 1 plus cosine of x, and that's going to be cosine of 390. X is 390. Okay, let's draw 390. 390 goes all the way around the circle. That's 360 plus 30 more. The reference angle is 30. Okay, so this angle would be 390. We end up with an angle of 30, the 1/2, and then rad 3 over 2. So that's going to be negative square root 1/2 times 1 plus the cosine of 390 is going to be this side, rad 3 over 2. Now this is, we're not going to worry about simplifying. What we're going to do is make sure that these two give you the same thing. Okay, so let's plug those both in the calculator. Okay, so I've got negative, do a controlled divide, rad 6 over 4 minus rad 2, control divide over 4, control enter. I get negative 0.9659. Okay, and then let's plug this in the calculator. We get negative square root of 1/2 times parenthesis 1 plus rad 3 over 2. I'll do a control divide, and we get the same thing. So we just confirmed that we get the same thing plugging in directly and over here, and that the formula does in fact work. So this was 1D on skills practice 114. Okay. Now this next one, G, is a little easier to do. 1G, because we've got sine of 1/2 x. Sine of 1/2 x, where x is pi over 2. So 1/2 x would be half of that, or pi over 4. Okay, so we're going to first do this directly. Sine of 1/2 x, so sine of pi over 4 is rad 2 over 2. That works out nicely. Now let's use the formula for sine of 1/2 x, which is plus or minus the square root of 1/2 times 1 minus cosine x. Now, 1/2 x we know is pi over 4. Pi over 4 is in quadrant 1. So the sign is positive, so we know it's the positive. So we can drop the negative. We have 1 minus cosine of x. Well, x is pi over 2. X over 2 was here. This was 1/2 x. So pi over 2 we could draw here. Pi over 2 gets you up here at 0, 1. We want 1 minus the cosine of x. Cosine of x is 0. So we get square root of 1/2 times 1, which is 1 over the square root of 2, which is rad 2 over 2. So that one was a lot easier to show that you get the same thing. Okay? Let's go on to the next one, just a couple more. So calculate sine 1/2 x, cosine 1/2 x, and tangent of 1/2 x for the angle described. Okay? So what we've got here, we're doing 2b. Cosine of x equals 5 over 13, and we know that x is between 270 and 360. Okay, so x is here, but we want to know where is 1/2 x. Well, 1/2 x is going to be in between half of that 135 and half of that 180. Okay, so we know that 1/2 of x ends up, that interval is quadrant 2. Okay, so if we have to find sine of 1/2 x, which is plus or minus square root of 1/2 times 1, I think that one's 1 minus cosine x. Okay, that's just from your formula sheet. 1/2 x is in quadrant 2, and quadrant 2 sine is positive, so we know that's going to be positive. We can drop the plus or minus. Then we've got 1 minus cosine x. Well, cosine x was given. Okay, and then we can simplify. Normally what we do, we actually draw x. We know that x is over here between 270 and 360, so that's over here. The cosine of x is, oh, I do that. No, it's not over here. It is in quadrant 4, which makes more sense. 270 is here, 270 is here, 360 is here, so we're going to end up drawing over here, which makes sense. The cosine of your angle should be positive. So the 5 over the 13, this is a 5, 12, 13, so that'll be negative 12. Okay. So we've got square root 1/2. This is going to be 13 over 13 minus 5 over 13, or 1/2 times 8 over 13. This reduces to a 1 and a 4. So we get square root of 4 over 13. Taking the square root of 4, you get 2. Taking the square root of that, you get rad 13, or 2 rad 13 over 13. And that was your answer for sine of 1/2 x. Okay, now let's do cosine of 1/2 x. Your formula for cosine 1/2 x is plus or minus the square root of 1/2 times 1 plus cosine x. Okay, so that's going to be, now in quadrant, remember, where is 1/2 x? Well, 1/2 x, we don't care where x is, we care where 1/2 x is in quadrant 2. And in quadrant 2, the cosine is negative, so we know that this should be a negative. And then for this, we have to look at where x is, because that's cosine of x. 1 plus, that's going to be 5 over 13. That's negative 1/2 times 13 over 13 plus 5 over 13 gives you 18 over 13, right? 5 plus 13, that's right, that's going to be a 1, that's going to be a 9, so you get negative square root of 9 over 13, or negative 3 over rad 13, or negative 3 rad 13. Oops, negative 3 rad 13 over 13. That's equal to cosine of 1/2 x. Okay. And if you want tangent of 1/2 x, you could do this divided by this. It's like almost everything cancels. You end up with -2/3, but let's use the formula just to practice using the formula. Tangent of 1/2 x. Remember, this is the nice formula where you can pick one where you don't have the plus or minus. Let's just use sine x over 1 plus cosine x. Now we drew x over here. Sine x is -12/13. Then 1 plus cosine x, 5/13. So we get -12/13 over 13/13 plus 5/13 is 18/13. The 13's cancel. You get -12/18 or -2/3, which is what we said we should get if we did sine of 2x over cosine 2x. Okay? And one last problem. We're going to do this identity on the bottom. We actually saw one similar to this last week. Okay. Now, you've got, this is going to be 3c. Sine of x over 1 minus cosine x. I'm going to leave some space. 1 minus cosine x over sine x. Okay. Now, yeah, you got to get common denominators. You could just jump to that, but we could look at this and multiply by the conjugate of the bottom. And if you think about that, hopefully we've done this enough that you start to see that that's been helpful and why that would be helpful. So 1 plus cosine x over 1 plus cosine x. The top, let's leave those, let's leave them factored for now. Sine x times 1 plus cosine x. And then on the bottom, you get 1. Outers and the inners cancel. And then you get minus cosine squared x. And then let's leave this one alone. Okay. Hopefully you recognize this thing is 1 minus cosine squared x is sine squared x. So on the top, we still have the sine x, and that's why I left this factored. Sometimes you want to multiply it out. Sometimes you want to wait and see if something cancels. This thing is cosine squared x, and now you can see why leaving that factored helps. You can cancel one of the sine x's. And that's especially helpful because canceling one of those sine x's is going to make our denominators the same. So that sine x cancels with one of these. We'll just cancel out the square. We've got 1 plus cosine x over sine x plus 1 minus cosine x over sine x. Okay, keeping your eye on what we want this to become. We want it to become 2 cosecant of x. Okay, our common denominator is sine x. So on the top, we've got 1 plus cosine x plus 1 minus cosine x. The plus cosine x and minus cosine x make 0. The 1 plus 1 gives you 2 over sine x, which can also be written as 2 times 1 over sine x, or 2 times cosecant of x. 2 cosecant x, and guess what? That is what we wanted to get. Okay, that's what this was supposed to be equal to. All right, and that's all for today. Thank you all for watching, and then you will just finish that quiz by end of day Wednesday. Again, I will have office hours Monday, at the end of the day. I'll just do probably 3 o'clock till about 3:30. I will be here as long as I get home from my doctor's appointment by then. I'll see you all soon.